check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury's the closest planet to the Sun, Venus is still the hottest one. Life on Venus, more like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel, or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
Get your closet ready. We're moving to Mercury. Your mission is to find out what you need to wear there to feel comfortable. So, Mercury is the closest planet to the Sun in our solar system. It's pretty hot here, about 800 degrees Fahrenheit, twice as much as your kitchen oven can produce. You need a heat-reflective suit like this. It looks like foil for duck roasting. The shiny, almost mirror-like surface reflects the heat rays and keeps everything inside from getting baked. That's you. This suit is designed to get to the hearts of volcanoes on Earth and can withstand up to 1,470 degrees Fahrenheit. That's twice as much as at the equator of Mercury. Oh, and bring an oxygen tank. Otherwise, you won't be able to breathe there. And you need to strap some heavy dumbbells to your legs. Mercury is smaller than Earth, and gravity is almost 3 times weaker here. So you have to increase your weight almost 3 times to feel comfortable. It gets extremely cold there at night, so you need to stuff your thermal suit with insulation. But even that won't save you from the cold. It's 3 times colder than at the North Pole. Plus, Mercury's atmosphere doesn't protect you from solar radiation as well as Earth's. So, you need to wear thick lead plates under your suit for protection. But the best thing to do is just evacuate from this planet. The next one is Venus. Although it's called Earth's twin sister, the scenery here looks frightening. A hot desert with volcanoes and clouds so dense that you can barely see the sun. These clouds contribute to the greenhouse effect. So, Venus is the hottest planet in the solar system, 890 degrees Fahrenheit. But the usual heat-reflective suit won't help you this time. The atmospheric pressure here is 92 times higher than on the surface of the Earth. That's like diving 3,200 feet underwater. So the air on Venus will just crush you. To survive, you need an airtight suit made of titanium or other sturdy materials. On Earth, we use an atmospheric diving suit like this to withstand the intense pressure underwater. It's like a mini submarine in the shape of a human body, and it's already equipped with an oxygen tank. Yes, the air on Venus is not only unbreathable, it's also toxic. The next planet is Earth. Just look out the window and decide for yourself what to wear today, okay? Let's go to Earth's satellite, the Moon. A few people have been here already, and they were wearing pretty big spacesuits. The main thing is to bring an oxygen tank. It's contained in a backpack along with the life support system. Even though it's cold, there's no atmosphere. It's almost a vacuum, and there's no air particles to take heat from your body, so you won't freeze instantly. Your suit itself should be airtight and keep the atmospheric pressure inside. The lower the pressure, the lower the temperature the fluid can boil over. In space, fluids from your body can evaporate in seconds. You don't want that, so you should wear a spacesuit. It'll also save you from dangerous solar radiation. The moon is defenseless against it. And the gravity here is 6 times weaker than on Earth. So you can jump 6 times higher and lift 6 times more weight. It makes sense to take a little weight with you, so you don't feel as clumsy as the first astronauts. Next stop, Mars. In summer, you could walk around here in shorts and a t-shirt. The highest recorded temperature here is about 95 degrees Fahrenheit. In colder times, you'd have to wear a sweater and a warm jacket here, maybe even 2. The average temperature here is slightly colder than the coldest point on Earth. But the atmospheric pressure here is frustrating. It's 170 times less than we're used to. Take the altitude at which commercial airplanes fly on Earth. Multiply it by 3. The conditions there are very similar to those on Mars. It's cold and there's no oxygen to breathe. Without a spacesuit, you'd last 2 minutes at most on Mars. So you need an airtight spacesuit on you all the time on the surface of Mars. NASA scientists are preparing a new generation of spacesuits that will allow astronauts to climb, crawl, and bend without difficulty. You'd feel like a real athlete on the surface of Mars. The gravity there is 3 times weaker than on Earth, so you could easily lift an animal the size of a tiger there. Don't forget to put a spacesuit on it, of course. Now let's fly through the asteroid belt further into space and arrive at Jupiter. It's the largest planet in our solar system, and it's a gas giant. That means there's no solid surface, so you can't even stand there. Although, hypothetically, you could jump into Jupiter. Then you'd keep falling all the way to the planet's core. Suppose you're standing on a platform just above the surface of the planet. The first thing you feel is the force of gravity. It's 2.5 times stronger here. You feel it pulling you down, and you can barely even jump up. So it would be nice to equip your spacesuit with an exoskeleton to support your body and help you move. Plus, it's incredibly cold. You'll feel the cold at about negative 229 degrees Fahrenheit on the surface of the clouds of the gas giant. And what makes things worse is the constant wind. It can reach speeds of up to 900 miles per hour, almost twice as fast as the speed of commercial airplanes on Earth. That kind of cold wind will instantly draw heat away from your body, so your spacesuit must be really thick and warm. But the pressure at the top of these clouds is almost the same as on Earth. Technically, you could even take off your helmet here if it weren't for the lack of oxygen and severe cold. Maybe Saturn promises better conditions. Another gas giant. The gravitational force here is almost the same as on Earth, so nothing will constrain your movements, except for a massive spacesuit. It's even colder here than on Jupiter, and the pressure here is about the same as about 15 feet underwater on Earth. So, the spacesuit not only lets you breathe and stay warm, but keeps your eardrums intact. Hey, hold on tight! You just almost got blown away by a gust of wind over 1,100 miles per hour. That's not unusual on Saturn. That kind of wind on Earth could get you from one coast of the United States to another in just 2.5 hours. The only option to warm up here is to jump down to the center of the planet. The closer you get to the core, the warmer it gets. But the pressure rises at a tremendous rate. In just a few seconds of freefall, even the toughest titanium suit will be crushed. Let's finally step onto a solid surface, Titan, Saturn's moon. It's 1.5 times the size of our moon and 80% heavier. And its surface is mostly composed of water, ice, and rock. The pressure here is a little bit higher than on Earth. You wouldn't feel any discomfort if it weren't extremely cold. Titan is 9.5 times further from the Sun than Earth, so our star can barely warm this moon. The air here is mostly nitrogen, just like on Earth. But oxygen is completely absent here, so it's impossible to breathe without a spacesuit. There may be a huge ocean beneath Titan's surface. Saturn's gravity heats up this moon's core enough to make the ice melt. Plus, it must be extremely salty, which means it can remain liquid even at very low temperatures. The next 2 planets are Uranus and Neptune. So Uranus holds the record for the coldest planet in our solar system. The temperature here is about negative 224 degrees Celsius, so bring the warmest spacesuit you have. They say if you jump to the center of Uranus, at one point the pressure becomes so high that it turns hydrogen into a crust of ice. And if you get even lower, you can see the rocky core. Neptune, in turn, holds the record for the strongest winds in the solar system. It's an ice giant, just like Uranus. So the dress code here is the usual: a super warm spacesuit, a tank of oxygen, and a heating system. So far, we don't have the kind of spacesuit that would help you survive on any of the gas giants. But if you get to the core of Neptune, it gets too hot. Its temperature is almost the same as on the surface of the Sun.